All right, today's lesson is all about a geometric series. So we will be adding the terms of a geometric sequence. Remember, with a geometric sequence, your first term A, or term 1, can be seen here. But these series or sequences have a common ratio, which can be found by taking term 2 and dividing term 1, or term 3 and dividing term 2, or any term and dividing it by the term in front of it, or the term before. If I do that, 6 divided by 2, 18 divided by 6, 54 divided by 18, 162 divided by 54, or 486 divided by 162, what do I get each time? What is the common ratio for that particular question? It's 3. Therefore, it's geometric. How do I know it's a series, not a sequence? What are between the terms? The addition signs. That's right. You're adding them up. Now, remember, for a geometric series, geometric sequence, sorry, this was on Tuesday, we use the formula Tn equals A, the first term, times R, the common ratio. R is raised to the exponent of n minus 1, where n represents the number of terms. Today we are going to look at the sum formula, how to add a geometric series. A still represents the first term. R still represents the common ratio. N is the number of terms. But notice it's not A times R to the n minus 1. The minus 1 is not in the exponent. So you would go R to the power of n, then subtract 1, then multiply by A, then divided by R minus 1 on the bottom. It says try solving the series above. Okay? First of all, we can count how many terms are in this series. 1. Anyone? 6. So I would be finding S6. Agreed? The sum of the first 6 terms. It's equal to the first term. Does anyone know what A is? A is 2. And we found R to be a what? So A is going to be a 2. I am going to open a bracket. R is a 3. And what I'm going to replace this n here with, if that one became a 6, this one becomes a 6. And then it's minus 1, close the bracket, and on the bottom, it's going to be 3 minus 1. Do a little math. What is 3 to the power of 6? Anyone? Is that good? What's going to happen here? Like, you could call this 728, double it, call it 1456, divide by 2. You're going to get 728. What would happen to these? What's like a quick way to do this? 2 divided by 2 is 1. Now I'm left with 729 minus 1, or 728. That is the sum of those 6 terms. Now, the formula in this case probably is a bit much. Like, I could have easily calculated the sum by just going 2 plus 6 plus 18 plus 54 plus 162 plus 486. And I'm going to get that same thing, 728. Fair? When's the formula become more beneficial? Yeah, when there's 33 terms, or when there's a large number of terms. If you're only adding 5 terms, I'll just bang them out, just add those 5 terms. Cool? And once again, we have the, so I'll go geometric series, and that was Sn equals A times R to the n minus 1 all over R minus 1. This if you're looking for a specific term or the number of terms. This if you're, I guess this formula would help you if you wanted to find an indicated term or the last term, if you wanted to find the first term or the common ratio or the number of terms. Those are the elements of that formula. This one helps you find the sum of, or an indicated sum of the first 6, 30, 40, 50 terms. You could use this formula to find the first term. You could use this formula to find the common ratio or the number of terms. Okay? Those are the elements of each formula. Now, if you flip your notes over, you should have something like this, yes? Let's try these questions together. What's my A value? What is the R value, the common ratio? 3 divided by 1, 9 divided by 3. It's 3. And what's N in this case? What do they want me to find? S what? S7. Okay, that's here. It says find the indicated sum. This is the number of terms I'm adding. That is the indicated sum. So remember the formula. A times R to the N minus 1 all over R minus 1. I'm going to find S7. It's going to equal my A value is a 1, my R value is a 3, and my N value is a 7. That's how you would build that formula. Make sure you get that down.
Me?
Yes.
Do you have Alexa Watling with you?
I do.
Have the option for her things, please?
No problem. All right, 3 to the 7th. What do we have the last one? 3 to the 6th? 729. So 729 times 3, 21 and 87, eh? 2187 is what we're looking at there. S7 is going to equal 1 times 2,187 minus 1 over 2. This is going to be 2186 divided by 2. 1,093. 1093. Is that okay? S7 is 1,093. If you added the first 7 terms of that sequence, of that series, you would get 1,093. S8. What is the A value in this one? What's the first term? 8. Thanks, John Boy. All right, what's the R value? See, Alexa. Careful, -4 divided by 8. +2 divided by -4. -1 divided by 2. -1/2, that's right, or -0.5 if you will. And what's the N value? It is 8. So when I go to fill this in, I'm going to have S8 equal to, my A value is an 8 as well. That's the first term. My R value is a -1/2. I'm going to put that in a bracket. Raise it to the power of 8. Subtract 1. Close the bracket. And on the bottom, I'm going to have -1/2. Subtract 1. Everyone ready to do some math? We're ready to roll on this one? S8 is going to equal 8 times, what would negative 1 to the power of 8 be? Positive 1. What about 2 to the power of 8? 256, attaboy. Minus 1, I'm going to subtract 256 over 256. Is that cool? And on the bottom, I'm going to write negative 1/2 minus 2 over 2. 1 whole would be 256 over 256. It would also be 2 over 2. Remember, in order to subtract fractions, you have to find a common denominator. This is going to be 8 times negative 255 over 256. And I'm going to divide by, what's negative 3 over 2? Wicked. How do you divide by a fraction? That's right, negative 255 over 256. And then instead of dividing by negative 3 over 2, do you agree that I could multiply that by 2 over negative 3? And I could do some reducing. 8 goes into 256. 256 divide 8, what do we get? 32. Okay, I could cancel this guy right here. 2 into 32. That would be a 1. This would be a 16. This right here, negative 255, is also divisible by 3. Gives me 85 if I reduce that. 2 negatives. What's a negative divided by a negative? Yeah, they're going to go away too, aren't they? Look what I'm left with. 1 times 85 times 1 would be 85. 1 times 16 times 1 would be 16. Now, if you multiply top by top by top, bottom by bottom by bottom, you could also reduce that. If I went 8 times 255 times 2, that gives me 4,080 over 256 times 3 gives me 768. All right, 4,080 over 768 reduces to 5 and 5/16, or 85 over 16. Completely fine to do it that way. You could call this a negative over a negative as well. It's going to make it a positive. Is that all right? If you added the first 8 terms of this, like if I kept going, I'd get positive 1/2, negative 1/4, positive 1/8, negative 1/16, and so on. If I add them all up, I'd get 85 over 16. Find the sum of the following series. Another example. I don't think you have this formula. Sorry, or this example. Would you copy that down? It says find the sum of the following series, 2, 4, 8, all the way up to 1,024. Now again, it might be more beneficial for you to just write this series, 2 plus 4 plus 8 plus, what would the next term be? 16 plus 32 plus 64, 128, 256, 512, 1,024. Add those up. Okay, it's only 10 numbers. Probably quickest to do it this way. But the answer should be the same if I use the formulas. For starters, what do I know? What is the A value? It's 2. What's the R value? Also 2. 4 divided by 2, 8 divided by 4. The common ratio is 2. I know it's geometric now because it has a common ratio. What if it had a common difference? What type of series or sequence would we be dealing with there? Arithmetic, that's right. Tn, the last term. Anyone see it? 1,024, wicket. N, what's the number of terms? It's 10. I know it's 10 because I just count those right there. How could you find n? How could you prove that n was 10? Suppose you didn't want to do this. Like, because if there's like 60 terms, I don't want to write 60 numbers down. I want another option for figuring out n to be 60. Yeah, I would use the first formula, find n. I would use the Tn formula, a times r to the n minus 1. That's the formula we talked about on Tuesday. I would fill this with 1,024. I would replace the a with a 2 and the r with a 2. Now, a couple options. One quick way to get rid of this red 2 would be to divide both sides by what? 2. 1,024 divided by 2 is 512. Is that okay? And then what would you do here? When you're trying to solve for an unknown that is in an exponent, what do you have to do? Yeah, you got to get a common base. All right? Now, I have a base of 512 on the left and a base of 2 on the right. The base of 2 on the right is the one that has the unknown attached to it. That's the base I want to work with. Does anyone know what 512 expressed with a base of 2 would equal? It's 2 to the 9th, Tenny. Good. If you didn't know, what could you do? What's the change of base formula? You take the log of 512, that's what I have on the left, and I want to change it to a base of 2. I could do the natural log, common log, either works. It would give me a 9. The exponent, the logarithm, is 9. So I rewrite 512 as 2 to the 9th. I drop the base from each side. I set my exponents equal to each other, and then I solve for n. I would add 1 to both sides, or I would drag the negative 1 across, move it from the right to the left, change it to a positive, and I would get 10 equal to n. Cool? It proves what I did up here. And the formula is better because it saves you from writing out 50 terms. This time it wasn't that bad. I only had to write out 10. What do I do from there? I have to find S what? S10, good. S10, I have to use my geometric series formula. It's going to equal A. What was my A value? A was what? 2, and what was R? So I'd fill out 2, the first term goes here, the R value goes in the bracket and in the denominator. And then, where do I put the exponent 10? On the 2 inside the bracket, wicket. So I am going to have S10 equal to 2 times 1,024 minus 1, all over 1. S10 is going to equal 2 times 1,023. I do the brackets first. Dividing by 1 doesn't change anything. S10 is going to equal 2,046. Now, what could you do to check where there's only 10 numbers? You could add these guys right here. What do you think they add to? 2,046. Booyah. Short one today. Do number 1 to 8. Leave out number 4.